Hello everyone, this is Mr. Mendoza. We're looking at CPM 124A. It says draw a diagram to calculate each of the following quotients. Okay, so here we have 4 and 2/3 divided by 2/3. Okay, first of all, let's go ahead and change the way we read that. We could say how many complete groups of 2/3 can we take out of 4 and 2/3? The diagram that I'll be using today is a number line. So notice here we have 4 and 2/3. We have a number greater than 4. So I'm going up to 5. Go ahead and make sure you have that drawn out. Start at 0. Now, we need to say how many complete groups of 2/3 can we take out of 4 and 2/3. So here we have our number line. I don't see the 2/3. So what I need to do is go ahead and take, starting with my one whole from 0 to 1, and cut it into thirds. Because our denominator is thirds, I'm going to take this one whole and cut it into 3 equal parts. So basically, I'm just going to go over 3 equal parts. That means I have 2 lines to work with. 1, 2. Now, for this one whole, I'll do the same. I'm going to take this one whole, which I have here, and cut it into 3 equal parts. 2 lines to work with. 1, 2. 1/3, 2/3, 3/3. So basically, I'm going to do that for each one whole. I'm going to continue. Follow the pattern. Thirds. Again. So I'm just going to darken this line here. Cut it into thirds. 1/3, 2/3, 3/3. Finally, I'm going to go ahead and take my last one whole and cut it into thirds also. Okay, now it says how many complete groups of 2/3 can we take out of 4 and 2/3? First of all, I'm going to go ahead and indicate 4 and 2/3. So here's 4, 1/3, 2/3. So it's right here. I'm just going to go ahead and indicate that so I know where I need to go or where I need to start. Actually, I'm going to go ahead and start at 0. Instead of starting at 4 and 2/3 and taking out, subtracting out, which is division, repeated subtraction, I'm going to go the opposite way today, and just to see it a little bit differently. I'm going to start at 0 and go up to 4 and 2/3. Okay, we could do it that way also. Let's see what happens. Okay, now I need to see how many complete groups of 2/3 can I take out of 4 and 2/3. So what I'm going to do is start taking out groups of 2/3. So notice here, so here's 1/3, 2/3, 3/3. So I'm just going to use this arc idea. So that right there, 1/3, 2/3. That's one complete group of 2/3. That's one group I could take out. Let me go ahead and do the same thing. 1/3, 2/3. That's another complete group of 2/3 that I could take out. Okay, I'll follow this pattern. 1/3, 2/3. Keep going. So far, we're able to take out 4 complete groups. Let's keep going. Finally, 1/3, 2/3. Remember, we're only going up to 4 and 2/3. And we could have done that the other way, going from here and starting to take out those groups. Okay, so now we have 4 and 2/3 divided by 2/3. So how many complete groups of 2/3 can we take out of 4 and 2/3? Well, let's see what we have. We have 1, 2, 3, 4, 5, 6, 7. Okay, so how many groups can we take out? We could take out 7. So we have 4 and 2/3 divided by 2/3 is equal to 7. Our next one we have B. Okay, now we have 10 divided by 2 and 1/2. Okay, so really we're going to start to say how many complete groups of 2 and 1/2 can we take out of 10? Okay, let's go ahead and draw it out. Go ahead and draw it out, please. So we're going to go ahead and in this case here we have a whole number of 10, so we can go right up to 10. So I'll start at 0, go to 10, make your lines. So cut it into 10 equal parts. Let's see if I have it right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. So this right here, we have our number line as our diagram. Let's go ahead and write out our problem. We have 10 divided by 2 and 1/2. Okay, now we have how many complete groups of 2 and 1/2 can we take out of 10? This time, let's start at 10. Because really, we're talking about we have 10 and we want to start taking out these groups, right? And we want to take out these groups. Let's start it like that. It's the same idea, really, but now we're just going to go from 10 and subtracting out equal groups, equal amount. Okay, so let's go ahead and start. So now it says how many complete groups of 2 and 1/2. So far notice here I do not see any halves. So what I want to do also is take my number line and start to cut it into halves. So I'm just going to darken this here and cut this portion into half. This one whole, the same thing. One whole, cut it in half. Here's another one whole, cut it in half. Follow the pattern and do the same thing. Okay, let's continue. So this one whole, cut it in half. All right, so now I can see. Now let's go ahead and take out our first complete group of 2 and 1/2. Okay, so here's, I'm going, there's 1, 2 and a half. That's a complete group, right? 1, 2, so I'm at 8, another half. Okay, now let's take out another complete group of 2 and a half. This time, since I'm on the half, I need to take out 2 and a half, but I think I'll start with the half. So here's my half, and then I'm at 7 now. So 7 minus 2, I get to 5, right? So I'm at 7 and a half. I'm taking out 2 and a half. I think I'll start with a half. Here's my half. That gets me to 7. And then I need to take out 2 more, so I get to 5. All right, so far we've taken out 2 complete groups, and we're halfway done, so we could already see what's happening. So most likely, right, it's going to be 4 complete groups. Okay, let's keep going. Let's take out another complete group of 2 and a half. So I'm at 5. I go to 3, 1, 2 and a half. My last complete group that I need to take out of 2 and 1/2, I'm at half. Let me go ahead and start. Here's half, and then 2 more, 1, 2. We get right to 0. A whole number, no remaining values. Excellent. Okay. So now we can count. I can count. Well, we started here, so I'm going to count this as our first group we took out, second group, third group, fourth group. So 4 groups, right? So we have 10 divided by 2 and a half, or we could say how many complete groups of 2 and a half can we take out of 10? 4 complete groups. We use this diagram to illustrate this idea. Excellent. Keep working.